Okay, welcome back everyone. So in this video we're going to be looking at kinematics, and the first example is from chapter 2, it's number 58, and it's a one-dimensional problem. And the second example will be from chapter 3, number 47, and it will be a two-dimensional problem. And so let's start with a 1D kinematics problem. So we're given that a spacecraft above the surface of a planet has a height as a function of time given by this expression here. Y of t is equal to b minus ct plus dt squared. And so we're given values for b, c, and d as shown. And we're trying to find in part A the initial velocity of the spacecraft. And so what we have to turn to here is the fact that velocity is the derivative of position. And so we want to take the derivative of y with respect to time, and so that's going to be negative c plus 2 dt. So that's an expression that works for all times. Okay, and actually if we plug in our numbers we get negative 60.0 meters per second plus 2.10 meters per second squared t. Okay, but what we want is we want the speed when t is 0. So we plug in a 0 and we see that our initial speed is negative 60.0 meters per second. So that's pretty straightforward. But notice that when we talk about the distance equation, x equals x naught plus v initial t plus 1/2 a t squared. Notice that this term in front of t represents v initial. And so if we go back to our original equation, negative c represents the initial velocity. Alright, now for part B, we need to find the velocity when the height is equal to 0. So the first thing we're going to have to do is plug in 0 for the height, and that's going to lead us to an equation that looks kind of like this. 0 is equal to, let's not forget, we have b is 800, and then minus 60t, and then plus 1.05 t squared. And I'm dropping the units, but you should always check and make sure that your units are consistent. In this case we have all meters and seconds, so I think everything's okay. So obviously what we have to do is solve this equation for our zeros. Okay, what is the time when the height is 0? Once we get that, we can plug that back into the velocity equation. Okay, and so what we can do here is just do a quadratic equation and say t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can plug this into Wolfram Alpha or use your calculator, and you'll find that there's two solutions, but the first one is when t is 21.2 seconds. Then what we can do is we can take that and plug that into the velocity equation. Remember that it's negative 60 plus 2.10 t. So that's negative 60 plus 2.10 times 21.2. And just a note on units, I have meters per second, and then meters per second squared and seconds. So those will cancel and everything will be in meters per second. So this velocity will turn out to be negative 15.5 meters per second. Okay, now There's another thing that we could do to check our work. We could use the so-called forgotten equation. Well, that's at least how I teach it in class. And this says that v final squared is equal to v initial squared plus 2 times acceleration times change in distance. Okay, so we could probably solve this in one step. Well, v final is what we want. V initial is going to be negative 60 meters per second, and we square that. Now we have to be careful because we want to make sure that we are consistent about our directions. And it looks like what we have here is a positive acceleration of 1.05, and then the distance will be negative 800 meters. Okay, another way to think about this is d final minus d initial. So that's 0 minus 800. Okay, and so then we can calculate this, and we find v final squared is 3600 plus, and then we have 2.1 times negative 800, and what that gives us is v final is equal to, or v final squared. So that's going to give us plus or minus 3600, 3600 plus 2.1, and the reason you saw the video jump is I actually made a mistake. The acceleration is actually 2.1, and so that gives us 4.2 here, and this entire term will be negative 3360, and that means that v final will be plus or minus the square root of 240, and that turns out to be, we choose the negative root, 15.5, so we get the exact same answer. Okay, so we're going to do the chapter 3 problem in the next video, so stay tuned.